So once we understand what a linear equation looks like, and again, this was only a two-step equation to solve, but the general steps, and that's first to get x's on one side of the equal sign, and everything else to the other side. Then last, we multiply or divide by that coefficient to get the x by itself. Okay, then what I always tell my students is the only way we can make the problems any quote-unquote harder is to create problems with more steps. So let's not worry about the right side for right now. But here on the left side, I have 4 terms in my initial equation. I have x's on the left and the right side of the equal sign. I have constants on both the left and the right side of the equal sign as well. So we said our first set of steps is to use addition and subtraction to get the x's on one side of the equal sign and anything without the x in it on the other side. So here with 4 terms in our initial equation, there are actually 4 correct places that you could start. If my goal is to get the x's together, then I can undo a 3x with a negative 3x. That means the x's on the left side are gone, and we just have negative 5 equals 2 plus 4x. If I went to the right side with the x's, then now I have to unhook this 2 to get the 2 away from the 4x term. So again, I can use subtraction. And my new statement says negative 7 equals 4x. My last step is to get rid of the 4 here, and I unhook times 4 by using division. And anything divided by itself equals 1. Our goal is to unwind or unwrap our equations until we get all the way down to 1x equals. Now, in my class for me only, and every teacher has their own preference and opinion and direction they want you to go. But in my class, when you solve for x, if you do not get an integer, meaning I don't get 2 or negative 3 or 14, okay, I always want you to leave that solution in fraction form. Okay, you need to reduce it to lowest terms, please. If you don't like improper fractions, you could write that as 1 3/4. But please don't call it negative 1.75. Okay. If you write it as a decimal on your homework quiz or test, I will take off a point, not because the value is not equal to what x is, but because you didn't follow the directions. Okay, so my verbal directions are always leave it in fraction form. Okay. The exception to that, the only time I want to see fractions in your answer is if they're, or sorry, always want to see fractions. The only time I want to see decimals in your answer is if there's decimals in the problem when you copy it out of the book. Okay, so if there's decimals in the problem when you copy it out of the book, then please leave it in decimal form. That's more than fine. Okay. Over here on the right, here's another example. And what we would need to do first, again, now we have more steps involved, but we're going to need to start using the distributive property here with the 4. We're going to spread everything out to see what we have sitting there looking at us. And then we'll put the pieces back together and go down the path we took over here. If you want to give this one a shot on your own, go ahead and pause your video. And then when you're done, turn it back on and I'll work through the problem. So the first step is to distribute the 4. And the one thing I didn't say over here is that, I kind of implied it, but subtracting 3x from both sides is not the only correct place we could have started. Okay, we could have added 5 to both sides. We could have moved the 7x by subtracting it, or moved the 2 in that first step. Students usually have a personal preference. Some students like to leave their x terms positive, always. Some students like their x's on the left side, always. Okay, so take the path that you like best. Don't go back and erase and say, well, heck, I have to do it that way now. Okay. Same thing over here after we've distributed and spread things out. Okay, the next good step, my advice would be the next step you should do is on the left side, go ahead and combine your like terms. Okay, 8 minus 5 here turns into 3. It's a good idea to do that before we start moving the x's and the constants to both sides, and I'll give a little sidebar explanation on that here in just a moment. Okay. If we move the x's to the left side, then we need to move that constant to the right side. And we get 3x equals 3. Next, we'll divide both sides by 3 and reduce to lowest terms. 3 divided by 3 is equal to 1. So we say our one solution to that equation is that x equals 1. Now, again, it's not required that you, as you move from here to there, that you combine those like terms. Some students just want to start moving things right away, and they'll come up here and say, I'm going to subtract 8 from both sides. Okay. Now, if I've written this on my paper and I take this path and go forward from here, what I've done is completely correct. However, what some students will do, and what I'll start seeing on their paper, is something like this. Okay, so think for a moment why that's not okay. If we keep track of where this equal sign is, right here, okay, notice that if I write this on my paper, I've subtracted 16 from this side of the equal sign. And over here on this side, I've not done anything. Okay. So if you have too many pieces involved, again, this is okay, this is not okay. Then sometimes your eyes will convince you to do something that's not correct. All right, or you'll misplace where that equal sign is and you'll start putting too many things on one side and not enough on the other. So again, my recommendation is if you have like terms to clean up between steps, that you take the time to do that. Call the 8 minus 5 equal to 3 and then go forward from there. When you're working through the exercises, I do want you to show me your intermediate steps. By college algebra, if you don't have to write minus 2 on both sides, that's fine. But I definitely want to see the black steps. Here, if this was the problem, I would want to see this step, and this step, and this step. If you need to still literally write down these steps here, please do that, because I want you to write them down if you need to see them to get it correct. But again, if you don't have to write it on your paper and you can see the 7 minus 3 in your head, the minus 5 minus 2 in your head, then you don't have to write the purple pieces down. I always say the only way to make the problems harder is to make more steps, create problems with more steps, or I will put fractions into the problem. Notice here with our fractions that there's no x's on the bottom of the fraction, it's just numerical values. Okay, we'll add the fractions in another section on down the road. Okay, the recommendation, and again, there's lots of different approaches. This isn't the only right way to start this problem, but the recommendation from me and the advice I'd like to give is let's find the common denominator for all of the fractions involved. And then let's use that common denominator to wipe out all the fractions, leaving us with an equation that looks kind of like one of these guys. So if I have 4 and 3 and 2 for my denominators, then the lowest common denominator I can build out of that is going to be 12. Now, the next thing I'm going to do is I'm not going to rewrite each of these fractions over 12. What I'm going to do instead is multiply every piece and every term of both sides of that equation times the 12. So I can clear all the fractions all at once. All right, my video is getting long, so I'm going to pause it and write the next step down. So it's going to snap up there like a finger, or like my finger snap. But I'll be right back. If you need to pause to get this written down, understand that 12 is 12 over 1. Again, recall that it gets multiplied by every piece, not just the first piece or the last piece in that equation. Next, notice here that I can reduce. 12 over 4 is 3. 12 over 3 is 4. 12 over 2 is 6. And then the pieces that we have left, we have our 3 times the x plus 3 minus the 4 times the x, all of that equal to 6. Right, go ahead and pause the video here, solve for x, see what happens. I just made it up off the top of my head, so it may not be pretty. But go ahead and pause the video, solve, and when you're ready to see the answer, turn it back on. All right, we distribute, we combine like terms. The x's are already on the left, so we move everything to the right. Don't forget what we're trying to solve for is positive x, and so if it's times a -1, I need to divide both sides by -1. I find out x equals 3. All right, so get a hold of me, please, if you have questions. We'll go to the book and do some odd ones. Okay. Let me know if you need help with this.